So we will be going over 3D shapes today, which includes volume, surface area, and Euler's formula. However, first we will be going over the homework review. Hopefully you all did the homework, and if you didn't, we're going over the top the three most missed problems. So this is problem question 8. So angle 3 and angle 6 are so it asks for the relationship between these angles basically. So angle 3 is this angle, and angle 6, angle 3 is this angle, and angle 6 is this angle. So what that means is that they're alternate interior angles. A lot of you guys got this wrong, so make sure you know your angle relationships.
Okay, the second most missed question. So find the value equals 11x minus 9 and angle 5 equals 7x plus 9. So first we need to figure out the relationship between the angles. So angle 1, and angle 5 is here. So you can see that they're both like in the similar position to each other, and their relationship would be called corresponding angles because you can see they're both kind of like above one of the parallel lines and to the left of the transversal. So what do we know about corresponding angles? We know that their measures are equal. So now we can set up an equation that says 11x minus 9 equals 7x plus 9. And then you just have to solve for that. Solve for x. So then you get 4x equals 18 and x equals 4.5.
Okay. So I am having a bit of an internet issue where everything is breaking up for me. So I am turning off my camera until it gets better. So question 10, if I draw two pairs of intersecting parallel lines with one of the angles formed with the measure of 60 degrees, how many other angles have a measure of 60 degrees? So to do this problem, we'd first want to draw a diagram. So we have two pairs of parallel lines, and by intersecting, they mean like this, right? So these lines are parallel and these lines are parallel. So if we know that this angle is 60 degrees, then we know this angle is 60 degrees because of vertical angles. And then we know this angle is also 60 degrees because of alternate interior angles. And then this is 60 degrees because of vertical angles. This is 60 degrees with alternate interior, vertical, vertical, same side, corresponding, and then vertical. So that would mean we have 1, 2, 3, 4, 5, 6, 7, 8 total angles with the measure of 60 degrees. However, it asks for other angles, right? So that means we have to subtract that one angle, which we originally counted, and we get 7 as our answer. Did you have a question?
Homework. Homework question.
Okay. If there aren't any questions, then we will be going over math counts problems. So these are some problems that do not really require any former knowledge of like any specific former knowledge, but this is many of them are mostly logic. So this question is, a soccer ball is constructed using 32 regular polygons with equal side lengths. 12 of the polygons are pentagons, and the rest are hexagons. A seam is sewn wherever two edges meet. What is the number of seams in the soccer ball? So, so in the chat, does anybody know how to solve this? Or unmute and say if you know any way you could possibly solve this. And if you don't know how you could solve this, also say that.
I have a question.
Yeah.
So, for like every pentagon there is, do we count that as 5 seams? And for every hexagon there is, do we count 6 seams?
So you could do that, but then you'd be over counting because you're counting each seam twice. Because wait, let me.
And then
try.
divide that by 2.
Yes.
Okay.
So yeah.
I think I know what it is.
Okay. So do you want to say it?
Yeah, I think it's 90.
So you are correct. So basically, okay. Okay, so basically the answer is 90 seams. So we know that there are 12 faces that are pentagons. So that means that we do 12. Okay, let me get a better card. We do 12 times 5 because there are 5 sides for every pentagon and we get 60. And then we know that the rest of the spaces are hexagons. So that means that there are 32 minus 12 or 20 sides that are hexagons. So we do 20 times 6, right? So that is 120. So we add 120 and 60 together and we get 180. But again, as stated earlier, we'd be overcounting the number of seams by, would be doubling the number of seams because we're counting each seam twice. So we get 180 divided by 2 and we get 90 as our answer. So that means there are 90 seams. So does anyone have any questions? Because understanding the logic to get there can sometimes seem a little hard, especially when you're starting off. So does anyone
I have a question.
Yeah, go ahead.
So it says a seam is seen whenever 2 edges meet, right? So that
Yeah.
doesn't mean for every side. It means for like every corner, right?
It means, okay, so say I'm just gonna draw a cube and then I'm gonna show what, okay, sorry. So say this is a cube, right? Then, wait, sorry, I'm still drawing it. Then, okay. Then these red things would be vertices, right? Or a vertex, right? Is one of these red things,
Yeah.
right? And then a side or this, okay. So this thing over here is an edge, as are these and these, you know, the sides of the faces themselves are edges, right? And then, okay. And then faces are these things, right? That coloring in, right? So yeah, they are not the same. It can be easy to mix up them because we're used to doing stuff in 2 dimensions, right? Like squares, circles, triangles, stuff like that. But make sure not to mix them up because you will get a different answer if you do. Okay. Does anyone else have any questions? If not,
Okay, problem 2. Each corner of a cube is sliced off, leaving a triangular face at each corner, and octagonal faces for each face of the original cube. How many edges will the new polyhedra have? So like the previous problem, this one just requires some logic. So feel free to attempt it on your own for a while. And if you have any ideas for like a simple strategy we can use, you feel free to unmute and say it.
What's a polyhedra?
A polyhedra, basically, you can think of it as meaning like 3D shape.
Huh? I didn't hear you.
Like a 3D shape that has lots of
shape.
sides.
Okay.
Yeah.
I am not quite sure how you get a triangular face if you cut off a corner on a cube.
Okay. So basically imagine a cube, right? And then like you're not just cutting off the vertex, you're cutting off a little bit past the vertex. So if you just slice that off, there's a triangle there, if you can imagine. It's probably kind of hard to draw. Yeah, like a Shawnee's picture, you're just cutting that section of the cube off. And then you do that to every corner.
I'm not getting this, so could you? Never mind.
Yeah, sure. We can go ahead and explain.
No, that's not what I was gonna ask, but I wanted some time to think.
Okay, then we'll go till like 3:13.
Do we just put the answer in the chat?
Yeah, you
So
can
what
put
do you
your
mean
answer
by
in the chat.
edges?
So if you remember Ishani's drawing previously, edges is just like the lines that form the sides of the shape.
So like, so what you're drawing to is an edge?
Yeah, what she's drawing is an edge.
Okay. Okay.
All right, so it looks like some people are saying 36. A lot of people are saying 24. So if you said 24, I imagine your thought process was like, there are 8 corners of the cube, and then each of them have 3 sides. So then 3 times 8 would be just 24. But you're missing a few sides. So actually the correct answer is 36. So good job to the people who got that. So the sides you're missing, remember that each face of the original cube kind of becomes an octagon. So if you can see, Ashani is going to draw like the sort of sides that you're miscounting. So this requires basically either you draw a picture or you can visualize this shape in your head. And if you count, there's going to be a total of 12 sides on top of the 24 from the triangles.
Okay, if no one has any questions, then we can move on.
I had a question.
Go ahead.
Like, why were you gonna count the sides? I thought you just count the triangle sides.
No, because, okay, so each of the faces is an octagon, right? So that would mean that you would get a shape that looks something like this, right? As each of the sides. And then you would have that for each of the 6 faces, or sorry, you'd have that for each of the 6 faces. So you would have like 8 octagons basically on top of another, right? Or not on top of another, but forming a 3D shape. So if you only counted the sides of the triangle, you'd only get these 4 sides, right? You'd basically be undercounted because you wouldn't be including this or this or this or this, right? So you count you don't only count the sides of the triangle because we're given that it has octagonal faces. If it said that each of the faces was like a diamond or a square or whatever, then you would be fine counting the sides of the edges of the triangle. But since we are given explicitly that it isn't, it would be incorrect to only count the sides of the triangles. Did that answer your question?
Yeah, thank you.
Okay. Okay, so we're just going to be talking about Euler's formula. So Euler's formula is a way to is a useful way for finding the number of faces, vertices, or edges given 2 of the 3. So the formula itself is V minus E, so vertices minus the edges plus the faces is equal to 2. So just as an example, and this only works for polyhedra, and polyhedra are 3D shapes where the faces are all polygons, right? So it won't work for like a cylinder or a sphere because you can't count the total number of edges or vertices, right? So okay, so let's take the example of a square pyramid, right? Just to demonstrate this, right? Then we'd get something that looked like this, right? And we would get, so we'd count the number of vertices. So in red, 1, 2, 3, 4, 5, right? So we'd get 5 vertices minus, and then we have to count the number of edges, right? So edges are 1, 2, 3, 4, 5, 6, 7, 8. 8, right? So we'd get 5 minus 8, and then we're going to add the number of faces. So we get 1 face, right? 2 faces, 3 faces, 4 faces, and 5 faces, right? So we get 5 minus 8 plus 5 is equal to 2. So this would basically simplify it to 10 minus 8 is equal to 2, which is 2 is equal to 2. So this works, as we can see. Does anyone have any questions?
No, wouldn't the answer be 8, which equals to 2?
No,
5 minus.
no, because we're doing 5 minus 8. This 2, this plus 5 is not in parentheses, right? If it were saying like parentheses, then yes, it would be negative 8 is equal to 2. But since this is plus 5 and this is plus 5, they sum to 10, right?
Oh yeah, I see it now.
Yeah. Okay. Does anyone have any questions? Any other questions?
Oh, and this formula is something you should write down. If you see a slide with like a pencil in the bottom right corner, that's something you should write down.
And yeah, I have another question. Why? What does this help us find out? The
So for example,
volume?
no, this helps us find out like the number of vertices if we're given the number of edges and faces, or the number of faces if we're given the number of edges if we're given the vertices and the faces, or like if we have one of those values, the vertices, the edges, or the faces, that is not given, then we can find the answer to that. We can find what that value is without having to really use, you know, much other, like without having to use like having to draw a diagram. And this is especially helpful if you have a very large diagram and you're asked to find the number of edges or the number of vertices or the number of faces on it, and you're given the other 2 values. Did that answer your question?
Yeah, I understand.
Okay. So we're gonna see. So does a cube satisfy Euler's formula? So in the chat, put your answer. Okay, so I'm seeing some answers in the chat, and yes, the answer is that it does fulfill Euler's formula. And this is because it is a polyhedron, right? So we can do we can actually sub it into the equation, and we get 8 minus 12 plus 6 is equal to 2. And we can see that that is true. So we know that it works on a cube. So if you guys ever forget Euler's formula and you need to use it in a math problem, right? Then what you can do is, okay, wait, sorry. What you can do is see, you can draw out a cube, and then what you can do is you can, if you know that there's a 2 in there somewhere and it's either addition or subtraction, you can see 6 plus 8, right? There's 6 faces, 8 vertices. So you add them together, you know it's 14. And then you know that there's a 2 in there somewhere. And then you know that there's a 12. So you could see 14 minus 12 is equal to 2, right? So that would mean the sum of the vertices and the faces is equal, minus the edges is equal to 2. So that's a way to remember it if you ever forget it. Does anyone have any questions?
I have a question. Why does it always have to end up being 2?
So there's actually a proof for it, but it involves higher level calculus, right? So there's no real simple explanation I could give to explain why it works, you know. And you can find some proofs online, but they're really hard to understand. So yeah.
I've figured it out.
What?
So it's just that it's always gonna end up being like that.
Yeah, it always will, for every polyhedron.
So it's never gonna be like 3 or 1 or 0. It's always gonna be 2.
Right, always.
Yeah, I even tried it out on this one. 8 minus 12 is -4, and -4 plus 6 is 2. So it's 2.
Yeah, it will always be 2 no matter what, unless it's not a polyhedron. And if it's not a polyhedron, then Euler's formula does not have to work on it. So keep that in mind. Okay.
Okay, so what is the sum of the number of faces, edges, and vertices of a hexagonal prism? So if you know what a rectangular prism is, a hexagonal prism is just one with the base is a hexagon. And so this one you can solve by just like visualizing it and counting the number of faces, edges, and vertices. But you can use Euler's formula to check your work. So once you're done, put your answer in the chat.
Are you gonna tell us how many faces, edges, and vertex there are, or do we have to guess?
You have to kind of figure it out. So, like I said, a hexagonal prism is just like a shape with 2 hexagons that are bases, and then like those are connected.
Is it 78?
I don't know, put your answer in the chat and we'll see in like a couple minutes.
I also have a general question. Is all this math supposed to just help us with math counts or just math in general?
Well, it's focused towards a lot of stuff you'll see on math counts, but of course it's going to help you like in school or whatever. All of these can be applied to a lot of different areas.
Okay.
I tried out for math counts on Friday.
You did? How
Yeah.
did it go?
I don't know yet.
Oh, well, good luck. I hope you get in. Okay, so I'll go ahead and explain this problem. 38 is the correct answer. So nice job to you guys. So let's say, like, hypothetically, we just imagine this shape and we found that it has 18 edges. So there's 6 edges for each base and there's 2 bases. And then there's also edges that connect the 2 bases. So then there would be 6 edges for one base, 6 edges for the other base, and then 6 edges in the area connecting them, which is what Shani's drawing right now. So for a total of 18 edges. And then now think about how many faces this shape would have. Well, it has 2 faces for each base, and then it has 6 faces on like the sides. So for a total of 8 faces. And then say you're too lazy to find how many vertices there are. So you just plug it into Euler's formula. And that would be v minus 18 plus 8 equals 2. So that tells you that there's going to be 12 vertices. And if you just think about that shape that would also, you can see that there's going to be like 12 points on the ends. And then so the question asks us for the total number of faces, vertices, and edges. So 12 plus 8 plus 18 equals 38.
Does anyone have any questions? If not, we can.
I
move
have
on.
I
Yeah.
thought like every face has to be an hexagon.
No, okay, so a hexagonal prism or any kind of prism. So say you're given the name of the prism is an n-gon prism, right? Okay. N-gon prism, right? So basically what that is that there are 2 of these n-gons or shapes which have that number of sides. So say that this is a pentagonal prism, right? Then it'll have 2 pentagons for its bases, and then it'll have lines between the edges, right? Which is how you find the number, which is what a prism is. So it's where you have 2 bases with shapes of an n-gon, and then the vertices are connected between one of the bases to the other, so that it forms rectangular sides like this one that I have shaded in, right? And that is what a hexagonal prism is, or any kind of prism. So for a hexagonal prism, you get something like this image that I drew earlier, right? Which is how you would get your answer. So does that answer your question?
Yeah, I understand.
Okay. If we don't have any other questions, then we will be moving on to volume. So there are 2 types, or there are 3 types of volume formulas or formulae of general formulae. So the area of a prism is always going to be the area of a base times the height. So this can be seen on the left. So you can see that this is a rectangular prism. So you would do length times width, which is the area of the base, times the height to find the volume, right? And then you could, for this triangular prism, you would do base times height divided by 2, which is equal to the base, right? The base is just the side that corresponds to the word that's in the name of the prism. So this is a triangular prism. So the base is the triangle side or triangular side. So you would do half of base times height, which is this, times the length, and you'd get the volume. And then a cylinder follows this rule since it is a prism with an infinite number of faces. However, it's not really a prism because a prism has to have a polygon base, right? Or polygon faces. It has to be a polyhedron. And this is not a polyhedron because it's a circle, right? So it doesn't have any edges, right? So it follows the rules. So what you would do is pi times pi r squared, which is the area of the circle, times the height, which is just height, and you would get pi r squared h, or pi times the radius squared times the height. So does anyone have any questions about that? And
Yeah,
also-
on the diagram of the circle one, the cylinder, why
Yeah.
does it say circumference if you don't use it?
So you would be using that for surface area, right? However, this diagram is right now we're only using this diagram for the volume. However, we will be going over surface area, which is why.
And I have another question. Does surface, I know surface areas covers the outside, but would it cover the inside too, or just
No,
one?
it would not. It would be like gift wrapping a box. You don't want to have it on the inside because it's not really useful. You aren't really using that inside area, right? So you would just be using the outside area. So just think of it as wrapping something up.
Okay, yeah, that makes sense.
Yeah. Okay. And then we will be moving on to the second type of general volume formulae, which is the volume of a prism. So the volume of a prism is 1/3 of the base times the height. So we can see for this rectangular prism or pyramid, sorry, the volume of a pyramid is 1/3 base times height. So the volume of this rectangular pyramid is equal to the base, which is or this is a square pyramid, is equal to a times a, which is a squared multiplied by the height, right? And that would be h, and then you divide it by 3, which is shown 1/3 base times height. And then for this triangular prism over here, you do the same thing. So the base times the height divided by 2 is equal to the area of the base. And then you multiply it by 1/3, so you get 1/6 base times the capital H height, so the height of the base, and then you multiply it by little h height, which is the height of the whole entire shape or the figure, and you get 1/6 base times height of the base times height of the actual figure. So then the cone also follows this property, and it also is technically a prism, a pyramid, right? But that's only because we aren't including the fact that it's not a polyhedron, right? So you would you would find the area of the base, which is pi r squared, right? Then you'd multiply it by the height, which is h, right? And then you'd divide it by 3 or multiply it by 1/3, and you get 1/3 pi r h. So does anyone have any questions?
This does not count as a prism, does it? Because it has a circle base.
It's a pyramid. So the difference between a prism and a pyramid is that a prism has like 2 faces, right? So a prism has 2 faces with that shape that is in the name. So like this would be a triangular prism, right? And it would have 2 triangular faces, right? It would have 2 bases with a triangular shape. And then there's the pyramid, which has a point or a peak, right? It has like a vertex where basically where all of the faces besides the base meet, right? So we can see that this is a triangular pyramid, right? Because my drawing is bad, but this is a triangular pyramid because it all meets at a point, right? There's only one face that follows the base, right? There's only one face that is the base, right? And just to make it easier to see that there's only one face, just like look at a square pyramid or a rectangular pyramid, and you'll see that there's only one face that is a square or a rectangle in that, so that would mean that it's a pyramid. So does that answer your question?
Yeah, but wouldn't that count? This the cone one would not count as a prism because the circle is not a polygon, but the pyramid would count as a prism because it has all polygons. Or no?
Okay, it would count as a polyhedron, not a prism.
All
there's
right, yeah.
yeah.
Okay.
But yeah, the cone would not count as a polyhedron, but the pyramid would.
For the wait, for the cylinders, is it base times height too, or is it like circumference times height, or what is it?
It's base
Yeah.
times height for the
Okay.
cylinder. Yeah. Okay. So we will be moving on to the last type of volume. So Yolanda.
Okay, so there's going to be one exception that doesn't fall into either category, pyramid or prism, and that is the sphere. So this one you're just going to have to memorize, so make sure you write this down. The volume of a sphere is 4/3 pi r cubed, where r would just be the radius of the sphere.
Okay, so hopefully you guys have written it down.
I'm almost finished writing. Can you hold it one more
okay.
second?
Yeah.
I have another question. Is the reason you categorize shapes into prisms and pyramids, is it because they have like some similar equation to solve for the volume or surface area?
For volume, yeah, it just helps you remember. So like all of the prisms are base times height, all of the pyramids are 1/3 base times height.
Okay.
Okay, so let's move on to a practice problem. Brandon has an 8-inch square pan, and Barbara has a 9-inch square pan. Both of the pans have the same volume. So what is the ratio of the height of Barbara's pan to the height of Brandon's pan? And you should express your answer as a common fraction.
Make sure to type your answers in the chat when you get them.
Wait,
What's
what
a
is
common fraction?
A common fraction just means like it's simplified as far as you can, but it's not a mixed number. So basically,
Got it.
like 3/2 would be a common fraction.
So it's just an improper fraction basically, and you, or if it's an, yeah, so it's just an improper fraction if it's greater than 1.
wait? Is like 8-inch the volume? Is 8-inch like the volume, or like
So like you have a square pan,
Yeah.
so that's 8 inches, 8 inches, and then some height that we don't know.
oh
but
okay.
you can find the ratios. Okay, So to solve this problem, first we have to realize that these square pans, those are prisms. So the way you would find their volume is just base times height. And so then the base would just be like the square. So the base for Brandon's pan is 8 squared or 64. And the base for Barbara's pan is 81, which is 9 squared. And so then we know that the volume of Brandon's pan is like 8 squared times its height, and Barbara's pan is 81 times its height. So, and then the volumes are equal. So we set those two things equal to each other. 64 times Brandon's height equals 81 times Barbara's height. So then if you want to find the ratio of the heights, then you just do 64 divided by 81 as your answer.
Does anyone have any questions on that? And if not, then we can move on.
I have a question.
Yeah, go ahead.
How could the pans have this volume if they have different heights and different surface area?
So the surface area doesn't really have an impact on the, like, it doesn't mean that the volume has to be a certain value. So basically, the reason that we're able to have this and this have the same area is like, if you think about it, like, let's just take another example, right? A different example. You can have a cube with side length 2, and it would have a volume of 8, right? And you can have a rectangular prism, right, with a base you can have a rectangular prism with a face that is a square that is 1 by 1, and it can have a length of 8, right? So you would still be able to have a volume of 8 despite them being like differently shaped. So the type of shape and like the size of the surface area doesn't really restrict it in like in its volume. Does that answer your question?
Yeah, thank you.
Okay. So we will be going over another math counts problem. So a rectangular prism has a volume of 240 cubic inches. Each dimension is increased by a factor of 1.5. What is the number of cubic inches and the volume of the enlarged prism? So put your answers in the chat, and if you have any questions, feel free to ask them.
How are we supposed to know which like dimensions they're talking about? Couldn't it be like
It's each of
it
the
could be
dimensions. So it's
uh,
length, the
but-
width, and the height.
yeah, couldn't it be like 60, 4 and 1, or it could be like 120, 2 and 1. How are we supposed to know which one they're starting with?
Either way, you would still get the same answer no matter what the dimensions are, so long as they multiply to 240 and each dimension is increased by a factor of 1.5, you will still get the same volume. I will try to explain that when I solve the problem, but yeah. Did that answer your question?
Yeah.
Okay, so I'll give you guys until 3:47. And yeah. Okay, it's 347. I don't think I have seen the right answer from anyone. So I will explain. So the answer is 810. So the length of the edges are 1.5 times greater than that of the original cube. So instead of length times
I just finished and I got 810. I didn't have time to put it in chat, bruh.
yeah, sorry about that. Okay, so instead of getting length times width times height, we'd multiply each of these dimensions by 1.5. So we would get 1.5 multiplied by length times 1.5 multiplied by width times 1.5 multiplied by height, right? So that would mean we'd get 1.5 cubed times length times width times height. So then what we would get is the areas of the sides are 2.25 greater than the original cube, right? Because that's 1.5 squared. And the volume of the object is 3.375 times greater than that of the original cube. So what we have to do now is we just multiply 3.375 by 810, or sorry, 3.375 by 240, and you will get 810. However, there's like a small typo here. That should be 240. But you should have gotten 810. So good job, Colin, although you did it later, or you got it right after I said it. So, okay. So we will actually be moving on to surface area, simply so we can get through it all, right? Okay, so surface area. So what is surface area? Surface area is just the sum of all the visible area on the outside of a 3D object. So it can be found by calculating the area of each face and adding the values up. So basically what you would do is you would, as I said earlier, think about it like wrapping up like a box or something. You wouldn't do it on the inside, you'd only do it on the outside. So unless it specifically says including the area inside of it, then do not like including the faces inside, right? Like if it were an open box, unless it says, you know, what is the surface area including the inside, then only do the outside. The only place where it would be like you would also use the inside is where it's like a donut shape and it's like it has a height and like that hole goes all the way through or it goes most of the way through, as long as you could like you know, see that, but they will always specify including the inside or not. So if they don't tell you, then it's on the inside. So oops, so the answer is on the screen. But basically, an example problem is find the area of a rectangular prism with side lengths of 9, 11, and 15. So the two largest faces have an area of 11 times 15, which is 165 each, right? And then the next largest faces, so the front and the back ones, have areas of 9 times 15, which is 135. And then the smallest faces have areas of 9 times 11, which is equal to 99. So that means that the sum of each unique face is 399, because 135 plus 99 plus 165 is 399. However, since there are two of each faces, we do 399 times 2 and we get 798 as our answer. So does anyone have any questions about that? If not, okay. So we could write out the formula for this. However, it makes more sense to know how to find the area of each face and sum them together rather than memorizing a formula for things like rectangular prisms, because it's easy to forget the formula or mess up the formula because it has like, you know, 3 different terms which are being added together and they're very similar. So you could mess up. And it might not make sense when you just write out the formula, you might get a little confused. So just remember the logic behind it. And for the other surface areas, we will be doing the formulas. We will not be doing the formulas unless they're unless it's a sphere. And or if it's a shape which is easy to remember or you need to remember. And it's hard to get the actual formula for.
All right, so like Ashani was saying, the sphere is just a surface area formula that you have to memorize. And so the formula is 4 pi r squared, where r again equals the radius. So go ahead and write that down. I'll give you around 30 seconds.
Didn't we already do this?
No, the volume formula is like very similar, so it's easy to get confused between them. Remember, volume of a sphere was 4/3.
Oh wait,
pi r.
this is surface area. I thought it was the same
Yeah.
exact thing.
Yeah.
Could you go back to the rectangular prism surface area? I didn't get that.
However, just like as I said earlier, it might make it easier for you to just remember the logic rather than writing or memorizing the formula. So whichever works best for you. Yeah.
Okay. So we're going to move on to a example problem. Say I have two spheres with a radius of 5 and 10. What is the combined surface area of these objects? So you can go ahead and try this. All right, so you can leave your answers just in the form of pi. So you don't have to multiply like the 4r squared by pi. You can just say 4r squared with a pi. Okay, so what you do here is you plug the values into the formula that was on the
Wait,
previous
is there
slide.
a special, like, you know how you have for volume you have to cube it, and then for oh god, for like volume you have to cube it, and for area you have to square it? Is there like something you have to do specifically for
Okay. Yeah, well,
this? Do you have to
surface area is just area, so you would square it. But remember, you have to find the area of like every single part of the shape.
Okay, I was just wondering.
Yeah, good question. Okay, so we're going to plug the radius values into that formula. So first we're going to do the sphere with a radius of 5, and that would be 4 pi times 5 squared. And then the second one, 4 pi times 10 squared. And so then you get 100 pi plus 400 pi for an answer of 500 pi. And again, you don't have to do like 500 times 3.14. It's perfectly fine to just say 500 pi, because most questions will ask you like express your answer in terms of pi. Okay, and now for surface area of a cylinder. So first we have to kind of imagine that we're just flattening out the cylinder. So imagine like we construct a cylinder out of paper and we're just going to open it up and smash it down. So you have the two circular bases of the cylinder, and then you have the middle part, which if you unravel it all out, it turns into a rectangle. And so now we just have to find the area of all of these. So for the area of the rectangle, that would be length times width. And we know that the length of the rectangle is just the circumference of the circle, which is 2 pi r. Then the width of the rectangle is the height of the cylinder. So then that means that the area of the rectangle here is 2 pi r times the height. But then we can't forget about the surface area of those smaller circular bases. So the area of a circle is pi r squared. There's 2 of them, so we do 2 pi r squared. And then we add all the circles and the rectangle together. So that means the final formula is 2 pi r squared plus 2 pi r h. And then that equals the surface area of the cylinder.
Does anyone have any questions? Okay. Okay, so I accidentally put the forgot the transition for the answer, right? So say I have a cylinder with the radius of 6 centimeters and the surface area of 168 pi centimeters squared. So what is the height? So obviously you guys can see the answer, but I'm just gonna draw like an image just to like help us visualize this, right? So we have the cylinder right here, and it has a radius of 6, right? So that would mean the bases are each 36 pi, right? So we'd get 72 pi are the bases, right? And we know that for the area of the rectangle, we get 6 times 2 pi, which is the circumference, or 12 pi, right? And then 12 pi multiplied by the height is equal to the area of the rectangle, right? So we know that this is equal to 168 pi. So then we just subtract 72 pi from both sides, and we get 96 pi as our answer is equal to 12 pi h, right? So we can divide both sides by 12 pi, and we get 96 divided by 12 is equal to 96 divided by 12, which is equal to 8. So does anyone have any questions? Okay, if not, okay, so we're going to move on to the surface area of a cone. So to find the surface area of the cone, again, let's flatten it out. So we get this, right? So let's label the net of the cone. So we can see that this red line is the slant height, right? Which is just the radius of the part that is not a circle, that is not a full circle, right? Of a cone, right? So that would be the radius if it were extended out to be a full circle. And then we have 2 pi r is equal to this green thing. And we know that because r is the radius here, and this this green line aligns with the circumference of this smaller circle here. So that would make that 2 pi r, right? So the circumference of the entire circle would be 2 pi s, right? Because the slant height is equal to, because the slant height is the radius if it were extended out, right? So it would be 2 pi s, which is 2 pi multiplied by the radius of this, right? But since this is a portion of the actual circle, if it were like completed, then to find what portion of that whole circle this is, we would do 2 pi r, which is this, divided by 2 pi s, which would be the circumference of the whole entire circle, right? So that would mean that r divided by s is what fraction of the whole circle this is, right? Of this whole circle with the radius of the red, right?
I have a question.
Yeah, go ahead.
I don't get why you added that circle at the bottom.
That's just the base of the cone.
Oh, then what's the cone, like the triangle thing you made on the top?
This triangle thing is, so if like, for example, if you have one of those like cones, right, like paper cones, and you cut it out, you'll see that that it's the part that isn't the wait, let me just draw this. So if you have a cone that looks like this, right, then it would be this part, right? So the part that has its base wrap around the circumference of that bottom circle. Does that answer your question?
Yeah, I understand.
Okay. So that would mean that the area of the non-circle parts, so the sector or portion of the circle here, is just pi rs, right? Which is pi times the radius times the slant height, right? Since it's s squared pi, or this the area of the whole circle times r over s, which is what fraction of the circle it is, and the s square eliminates the s in the denominator, and we get pi r s. So that means the area of the circle is just pi r squared, right? The area of the circle down here is just pi r squared. So we sum them together and we get pi r s, which is this, plus pi r squared, which is the base. Does anyone have any questions on that? If not, okay. So we're just going to quickly do an example. Find the surface area of a cone with a radius of 3 and a height of 4. If you need to draw a diagram, it helps. It might help you. So we're going to do this problem. I'm going to give you guys 3 more minutes. And then we will go over pyramids. And if we have time, we will try to do the breakout room activity. Okay, so I am seeing a few answers, so I'm going to go over the problem. So we know that this part that's like slanted, that isn't the circle, that isn't the base, has an area of pi r s. So we can use the Pythagorean theorem to find that s is equal to 5, right? Because 3 squared plus 4 squared is 5 squared. So that means the slant is 5. So we do 5 times the radius, which is 3, times the slant height, which is 4, and then we multiply that by pi, and we get 60. No, we multiply 5 by the radius, which is 3, and then we multiply that by pi, and we get 15 pi, right? As the area that is not the base, right? And then we have to find the area of the base, and we know that the radius of the base is just 3. So we just do 3 squared pi, and we get 9 pi. And then we sum 15 pi and 9 pi together, and we get 24 pi. So good job to everyone who got that answer. Good job to Zane. Yeah. Okay. Okay, so we're going to quickly go over rectangular pyramid, and then we want to get through the breakout room activity. So let's, so I'm just gonna talk through this, right? Because, you know, yeah. Okay, so let's try to find the surface area of a rectangular prism with a length of 15, a width of 6, and a height of 4. So we have to draw a diagram. So you can see on the left that we have drawn a diagram. So let's just
I have a question.
Yeah, go ahead.
So you said this is a prism, but isn't this a pyramid?
This is a pyramid. Did I misspeak?
Yeah, you said prism.
Oh, okay. Sorry about that. Okay, so yeah. Okay, a rectangular pyramid. So let's just list out the types of faces it has. So it has a rectangular base, or a rectangle for a base, and it has 4 different triangles. However, these triangles that are on opposite sides of each other have the same area because they have the same base and the same height, right? So we can see that the base has an area of 90. So we have gotten that out of the way. Now we just have to find the area of this light orange face and this dark orange face. So we would first try to find the area of the light orange face. So first we'd have to find the height, right? Or we'd have to find the height of this light orange face. So what we would have to do is we would use the Pythagorean theorem. So we know that this whole side is 15. And since this is the center, that means that it's divided this length of 15 into 2 equal parts. So that means that this yellow side over here is 7.5, right? And we know that the height is 4, right? So what we'll get is 8 for the, we will get, we're gonna get 8.5 for the height of this, for this slant height, right? So we do 8.5 times 6, right? So we have this height as 8.5 because we have done 4 squared plus 7.5 squared and found that it's equal to 8.5 squared, right? So we have the height as 8.5 for this side, right? And then we do 8.5 times 6 divided by 2. And then we get the area of that face. So 8.5 multiplied, and then we multiply that by 2 since there are 2 faces with that area. So effectively the divided by 2 and multiplied by 2 cancel out. So what we get is 8.5 times 6, right? And that's just equal to 51. So we had that over there. And then to find the area of this face, right, we do the same thing, right? We know that this 6 is divided into 2 equal parts. So this is 3. And then we get the height of this then is 5, right? So we just do 5 times 15 divided by 2, which is the area of one face. And there are 2 faces, so we multiply it by 2. So we get 5 times 15, which is 75. So we add 51 and 75 together, and we get 126 as the surface area, not including the base. Now we have to add the base to this, and we know that the base has an area of 90 because we did that earlier. So 126 plus 90 is equal to 216, making our answer 216. Does anyone have any questions? Do you have any questions?
I have a question about the slant height.
Yeah, go ahead.
So how does that work with why did you use the slant height for that equation?
So the reason we use that, this is the Pythagorean theorem, which is just 1 leg squared plus 1 leg squared is equal to this squared, right? So we find the square root of both sides, and we just find square root of the height plus the square of plus the square of the length of the other leg, right? And the reason we got this was because we used the Pythagorean theorem, right, to find that. And the reason we found the slant height was because the slant height was the height of this entire light orange face. Does that answer your question?
Yeah, but wouldn't that also work for the light orange?
Yes, however, this horizontal lengths are different because we're dividing the side that's parallel to it by 2. So that's what we did for both the dark and light orange faces.
Got it.
Yeah. Okay, so we are going to try to do the breakout room activity. So, okay, copy link address. So in the chat, I'm gonna, okay, well,
Okay, so Ishani put the link to the form in the chat, so go ahead and open it, and you can go ahead and fill out stuff. Okay, so the rules to this breakout room activity, there's going to be 10 problems in the Google form once we unlock it, and you have 15 minutes to do as many as you can. Everyone here is going to get divided into 3 different breakout rooms, so 4 people per room. And then we probably won't have time to go over the problems, but we will figure out which team won at the end, okay? So you guys need to work together to solve all of your problems, and you should unmute and basically, yeah, make sure everyone's participating. Then fill out the Google form with your answers as you go along.
I have a question.
go ahead.
On the Google form, it says what class are you in? Is this class 1 or 2?
This is class 1.
Okay.
Okay, so I'm gonna assign you guys to the breakout room, and before I do that, I'm gonna put a link to the Jamboard or the questions in the chat. Make sure to work with your team, and whichever team gets the most amount of questions right will be the winner. So open all rooms.
Excuse me.
Join.
Yeah, go ahead.
I don't have access to the slide.
Oh, make sure you're not using your JCPS email. Your JCPS email will not allow you to access it. Yeah.
It doesn't let me in any other email.
Okay, or you can ask someone else in your breakout room to like share their screen.
Yeah.
Okay.
So Japji and Yug, you have been assigned to breakout rooms. Can you, yeah. Are you having any problems, Aniket?
Yeah, what is the password?
Oh, sorry. The password, okay, is, okay, Yolanda. Okay, the password is this, but I'm gonna broadcast it to everyone.
Should I return to my breakout room?
Yeah, you can.
What's the password?
I broadcasted the message to everyone just now. If you have not gotten it, that is the password.
Okay, thanks.
Yeah, you're welcome.